All right, I guess we'll get started. Can everybody hear me? All right, cool. So yeah, welcome to my talk on Rust. I called it yet another talk on Rust because if you guys go on YouTube and you guys search up Rust talks, it's pretty much going to be talking about the same thing that I'm talking about. But there's reasons for this, and it's like you kind of have to know all this stuff if you want to get into Rust. So it's kind of repetitive, but yep, here's another talk about Rust. So we'll be covering what is Rust, and then we'll also be talking about what makes Rust unique. I'll be showcasing some of Rust's features, and then we'll be talking about what are its use cases, and also who is using Rust right now and how you can get started with it as well. Feel free to ask questions while I'm speaking. If you guys have any questions, I'll just answer them. Just a little bit about myself. I'm a fourth year now studying software engineering at UTSC. I'm in the co-op program. I worked at Ministry of Education, IBM, and Spire Trading. And I started using Rust back in 2018. A little bit about myself is I have a cat, and it's on the bottom right. Yeah. Curious? Can you tell us more about the cat? It's white. I'm curious about all of you guys. If you guys could tell me about yourself, what program you're in maybe, and like why you wanted to come to this talk and how much experience you have with Rust. Okay.
I came because of Richard Hong.
Okay. I see. Okay. Yeah, so what is Rust? And we're not talking about the game. There's so many times where you go on the Rust Reddit forum and you see somebody saying, I keep losing at this game or something. We're talking about the programming language, not the Rust game. Yes, it is a lot faster than JS. Yeah, so Rust describes itself as a blazingly fast and memory efficient with no runtime or garbage collector. It's a programming language made by Mozilla back in 2006. The first stable release came out in 2012. And the reason they made it was because the developers couldn't find a suitable programming language to serve a niche where they wanted fast and safe programming language for systems programming. And it kind of competes with C and C++ and Go. A lot of people compare Rust to them a lot. The syntax is pretty similar to C++. And right now, Rust is being experimented with in a lot of different areas. And we have Ferris the Crab, which is the mascot for the programming language. Yes, we will be comparing it to Java as well. What does memory safe mean? So if you have any experience with, let's say, C or C++, you have to manually manage your memory. And what happens is if you do something wrong with your memory, you end up getting a segmentation fault or something. Or if you do an index out of range, it's not going to detect it. It's just going to keep running as long as it keeps working. So this could be really dangerous where like you have a buffer overflow and it overwrites your data or overwrites your return address, and it makes your program jump to some other part of the code where you might have people might have inserted malicious code in your program. Kind of sidetracked, something I wanted to share that I found recently is this process called carcinization. And it's the process where decapods, which are like shrimps, lobsters, and crabs, it's the process where decapods slowly evolve into crabs. And the reason behind this is because the crab body plan is actually the ideal body plan for these animals, which is something really cool. And I thought it was a nice metaphor to have. You know, as you try to squeeze more and more performance out of your program, eventually you're going to move over to Rust. Yeah, here's a sample piece of code in Rust. We have our main function. We have a variable a that equals to the string world. We print it out. Then we have another variable s equal to 0, and it's going to be the sum from the numbers 1 to 9. And then we print it out. We get some output, hello world, and 45. Everything straightforward here. What does the exclamation mark do? So the exclamation mark is actually, what it means is print line is a macro, is not actually a function. Macros and functions are a little bit different, but for the purpose of this, it's pretty much like a function. So why would you want to learn Rust? Like, what makes Rust unique? We can basically use any other programming language, right? We have Java, we have Python, we have JavaScript, we have TypeScript, we have all those. Do you know where are you talking about the exclamation mark comes from? Julia Lang has a similar exclamation point, but they use it to denote purity. I'm not really sure. I think it's just they ran out of symbols to use, or they just thought it was a nice symbol to use. I'm not too sure the reason behind them using exclamation point. So the first reason that makes Rust unique is it actually has no garbage collector, but you also don't have to do any memory management. So how many of you guys know what a garbage collector is?
It's like that thing in Python where after program execution, all allocated memory gets freed up.
Yeah, sort of. It's basically like a program that's built into the language. It's part of the program's runtime. And it basically manages all the memory for the user without the user having to do anything. So this is the case for languages like Python, Java, JavaScript, Go, Ruby, Erlang, C#. Pretty much any modern programming language has this. So developers don't have to manually call malloc and then manually call free and so on. So yeah, basically automatically allocates memory and automatically frees memory. And without a garbage collector, developers do everything manually, like in C or C++. Let's say you to the scope style of C++ with the destructors. I don't know what the question is asking, and I'm not that familiar with C++, so unfortunately I cannot answer that. But yeah, so if we take a look at traditional programming languages, languages have all either been garbage collected or manually managed. With garbage collected languages, the language facilitates and manages the memory for the user. And this has some advantages, such as it's easy to use. You can get things running really quickly, and you don't have any memory bugs like leaks or double freeze and so on. But the disadvantages is it's slower in performance, and often it has unpredictable behavior, or unpredictable performance, I should say. So when the garbage collector needs to clean up the memory, it stops your program for a split second to run the garbage collection. On the other hand, where you have non-garbage collected languages, user is responsible for managing the memory themselves. It's fast and predictable because you know when to, you're the one that's doing the allocating and freeing. Has a small runtime because there's no garbage collection. But the downside is you have a small runtime, so you don't have garbage collection, you don't have green threads and some other neat features. And it's also hard to use, right? Or it's harder to use. It leads to a lot of bugs. And I think somewhere it says like some stats say, I think Microsoft had it where like 70% of all their bugs were like memory related bugs. So yeah. And if we were to plot like a graph on about this, we kind of have where we have on the x-axis safe and not safe, and on the y-axis we have slow and fast. We kind of have C and C++ and assembly all the way on the top left. We have all the other interpreted garbage collected languages on the bottom right. Of STL container actually beats out garbage collection. You verily. Yeah, no garbage collection is definitely faster than garbage collected for the most part. So yeah, we have our manually managed memory languages, and we also have our garbage collected languages. Now, if we were to plot Rust on this, it's kind of right there. You know, it's fast and it's safe. So how is Rust able to achieve this? You know, no other languages was able to do this in the past. We either had garbage collected or non-garbage collected, big runtime or small runtime. Is it possible to manually manage my own memory in Rust if I really want to? Yeah, there's like a unsafe keyword that lets you basically jump down to C level. It's a little harder to use than C, I think, but that's just because of the syntax. Which leads on to our second point on why Rust is able to achieve this, and it's because of Rust's ownership and borrowing system. Now, if you take in CSEC B36, it's kind of the same idea here, where we're mathematically proving our program is correct. I don't know how many of you guys took B36 yet. Yeah, it is a pretty theoretical, proving all those programs. So the Rust ownership system basically states that each value in Rust has a variable called its owner, and there basically can be only one owner for that value at any given time. And when the owner goes out of scope, say when the function ends or if the if statement is over, the value gets dropped, meaning the value gets freed up and the memory is no longer in use. And the borrowing system says that at any given time, you can either have one mutable reference or any number of immutable references. Now, references are basically like pointers. If anyone is unclear about that, you can ask. And references must always be valid. What this means is these pointers can't point to memory that aren't allocated for the program. You know, in C or C++, you can, or in C, you can point pointers to pretty much anywhere you want. And even if you don't own that memory, and sometimes it's going to crash, sometimes it's not going to crash, it's really hard to figure out these bugs. That sounds really annoying to manage. Are you talking about the ownership system and the borrowing system? The borrowing specifically. Yeah, the borrowing is a bit annoying. There's a thing called the borrow checker where everyone has to fight with it when they first start using Rust, because the borrow checker keeps telling you your program is wrong, and you know it's right, but it won't compile because it keeps telling you it's wrong, and then you have to fight with it until you figure out how to write your code properly in Rust. An analogy that I made is like kind of like a notebook full of course notes. You own the notebook full of course notes. It's written by you. All your friends can read it at the same time and copy it into their notebook. But your friend can't read it while you're writing to it because you're covering your page or something. And you're responsible for recycling it when no one else needs it anymore, including yourself. But you can also give your notebook to a friend. Maybe they're taking it next semester and they really want it. So here's a program in Rust. We have two variables, A and B. A has a string value called hello world. Then we're going to set B equal to A, and then we're going to print out A. Now, how many of you guys think this program is correct? Or like, if you think it's not correct, why is it not correct? looks fine because you're not mutating any of your references. Well, this program is actually not correct. We get this error message saying that a move occurs because of a has type string, and value moved here and value borrowed there. It's basically saying, we have the value a, and a is the owner of hello world. Then when we do b equals to a, we're now giving ownership of what a was to b. So now b owns the value of hello world, and a is now invalid because a now no longer has a value because it's not an owner of anything. So when we print out a, it's going to error out. And we can see it in our error message saying value borrowed here after it was moved to b. Does that make sense? They can't both be immutable references to string, or do we need to annotate that somehow? Yes, that is, we would need to annotate it. We use the ampersand sign to say that b is going to borrow the value of a. And when we do that and we print it out, it's still fine. We have one owner, a, that owns the value of hello world. And then we have one immutable borrower, b, that is borrowing the value that a points to, or a owns. Does that make sense? What are the types of a and b respectively? So a would be a string type. I'll type it out here. So a would be a string, and b would either be a reference to a string or a reference to a str. I won't go into too much detail about the differences, but yeah. So here's another program. Reference does not equal pointer. I use them interchangeably, but maybe they're different. But for the purpose of this talk, they're pretty much the same to me. I might use them interchangeably. So here's another program. We have a mutable reference or mutable variable a, b, and c. And we're going to assign b and c as a mutable reference to a. Now, is this correct? Or will this compile? Right, not allowed to have multiple mutable references. So if we go back to our borrowing system, it says at any given time, we can only have one mutable reference. So we're going to get an error saying first mutable borrow occurs here, then second mutable borrow occurs there. There's many different ways to fix this. Usually depends on how you designed it, and usually never want to have this kind of situation because this leads to data races. Another example here, we have a equals to hello world again. We have c equals to the reference of a. We're going to have an immutable borrow of a. Then inside our brackets, so now we're creating a new scope, essentially. We have a new value b, and we're going to make it equal to a, b, c, d, e. And then we're going to set c equals to the reference of b. Then we're going to print out c. Is this program okay? Will it compile? Probably not. Seems okay. Again, this is not going to work, this program. And the reason is because b doesn't live long enough, right? We said in our borrowing system that all references have to be valid. But the problem is c is valid for the entirety of our main function, whereas b is only valid within the squiggly brackets that we've created. So after the squiggly brackets is over, the value B is going to be deallocated and freed or dropped. But C is still going to be pointing to B, which is now invalid. So we basically can't do this. Again, solutions for this is really depends on your program and what you're trying to do. In our previous slide, in this slide, we talked about living long enough, and there's actually a thing in Rust called lifetimes where we can specify how long a variable lives for. So when we make functions, or if we make structures, we can indicate how long something lives. So we're basically telling the compiler, hey, this reference for sure is going to be valid for the entirety of this function or something. So in our top function, we say S1 has a lifetime of A and S2 has a lifetime of B. And we're going to return a string with a lifetime of A. But in our function, we can return S1 or S2. The problem is they're different, they have different lifetimes, right? S2 has the lifetime of B, which is not equal to A. And these are just placeholders. So you basically have to change your function to be A. This is a little bit more advanced, and you usually don't have to worry about this unless you're doing some more complicated stuff where you don't want to copy around values. We won't be going into this in detail. Just something cool to show you guys. Now, what this basically entails is that by using the ownership and borrowing system, Rust can basically guarantee that we don't need to do any memory management and no garbage collection, because now it's able to figure out exactly how long we need each variable for and exactly when to free them. So no memory management and no garbage collection. In addition to that, because we're so strict, we actually have no data races. A data race is basically where you have multiple threads mutating the same value, and when you're trying to read that value, you're going to get garbage output because maybe something was writing it, it was halfway done, and then your pointer points and tries to read it, and it's only half of it is valid. By having only one mutable reference, we avoid data races. Another thing is we're very confident that our code works if it compiles. You almost never run into a, I guess, runtime exception or something when your Rust code compiles. There are some downsides to this. You have to fight with the borrow checker a lot in the beginning because you've written programs in the past with other programming languages and they allow you to do a lot of these things. But with Rust, you can't really do these. And it also leads to some non-trivial solutions for certain data structures, especially the ones that are linked. Because let's say you have a linked list. Well, who's the owner of the node and who's the owner of the node it's pointing to, right? It gets really complicated on who owns what, essentially. Any questions on this? All good. All right. All right, the third one is a little bit more fun, I guess, in my opinion. And it's like Rust has really nice new language features. It's really fun. It's really enjoyable to code in. I haven't found another programming language like this where it's like you're writing a lot less code and it's like doing a lot more, and it feels very fun to use. And also declarative programming is very nice. I have not used C++20 yet. I should probably learn C++ at some point. Yeah. Type inferencing. If you looked at if you saw in my previous examples, I never really had to specify the type of a variable. And it's because the Rust compiler can basically make inferences or make assumptions on your variables. If it equals to a string, then it knows it's going to be a string variable. So that's something that's really cool. You don't have to type out your types like in Java or some other statically typed languages. And you can, it's also pretty useful for certain functions. Say here we have a heap and a hash map, but it equals to exactly the same thing. We have A as a vector of a tuple with a character and an integer. We have 3 of them. And if we call a.iter, which creates an iterator, and then we map it, and then we collect it, basically collects all the values in our array into a binary heap. But if we do the exact same code, but now we're telling the compiler that, hey, now it's a hash map now that maps characters to integers. And it's just going to automatically know how to do it. You know, we're using the exact same code, but we're converting it into a different data structure, and Rust is able to figure out exactly how to do it for us. So no longer, we don't need to initialize our binary heap and then create a for loop and then insert it, or have create a new hash map and create a for loop and insert it. So that's something pretty cool. What does the x do? So it's basically it's basically a lambda function or a closure, because when you do an iteration, it's going to give you the references of the values inside our array, and I'm going to do star x to dereference it so we actually get the value. Yeah, it is a lambda function. Another cool feature is enumerates. Now these enumerates aren't the same enumerates you see in Java, C, or C++, or C# or whatever. You know, in these languages, we have an enumerate. We basically specify the values. Say we have IP version, the IP version, we have v4 and v6, and then we'll create like a class of some sort that has a version inside. And then maybe we'll also have a function that returns us the address. But other than that, we can't really do anything. They're basically numbers, right? V4 could be equal to 1, V6 could be equal to 2. And then when we do a switch or we do a comparison, it's basically just comparing numbers to numbers, which is really fast, which is why you would want to use an enumerate. But in Rust, the enumerates can be a lot more powerful. You can see here in our IP address enumerate, we can actually assign values or fields to our enumerates, right? In the IPv4 version of the IP address, we can assign 4 unsigned 8-bit integers to it. In the v6 version, we can have a string assigned to it. And then when we initialize it, we can just give the numbers. And you can do this with other things as well, maybe some sort of authentication system that has a password as a string, a PIN as 4 numbers, a pattern, a grid, fingerprint, and so on. Really changes how you program certain things. Any questions about this? So it's a namespace. Not sure if it's like a namespace. Not really a namespace, but it's like there's kind of like type classes in Haskell, I think, or something. I forgot what it was called in Haskell, but they have something similar to this in Haskell. How is this related to an enum? So in typical languages, your enum can only have one value, right? It's either v4 or v6, and you can't really assign any values to them. Whereas in Rust, you can have multiple values to them. You can have structures inside of them, and yeah, it's pretty cool. Does that answer your question? But that makes it not an enum. I mean, in Rust, it kind of compiles down to be, I'm not really sure, but that's how enums work in Rust. In this example, is a namespace v4, v6. Yeah, you can think of it like that, yeah. Yeah, I think if you look at the memory of it, it would probably be pretty much a namespace with structures inside of it. Which makes sense because whenever you're comparing, it would just be comparing the memory values. Another thing is traits. I don't know if they have this in C++, you can tell me, but in Java, we have interfaces, and you can create your own interface, you can create your own class, and your class can implement your interface, basically. But what if you wanted to implement the interface for a class that's not part of your program? Say you wanted to implement your interface for the string class that's part of the Java language. Well, it's not going to let you do that, right? Interfaces, you can only implement it for your own classes. Well, with Rust, you can do that, which is pretty cool. You can implement, you can specify your own trait, which is basically like an interface in other languages. But then you can also implement that trait for structures that are not part of your package, say for the string structure or for a hash map, which could be pretty useful. Say maybe you want to find like the largest value in a hash map, and you don't want to write that multiple times. You could add a trait to it and then call a method. Type traits were meta programming in C++ 17, but it was really hacky. We have concept which clean. Yeah, C++ is getting pretty good these days. Next thing, pattern matching. This one's really nice. In your typical language like Java, C, Python, JavaScript, and so on, maybe say you have a class or you have a structure and it has some sort of values in it, right? And you want to do some evaluation on this. But it gets really messy if you want to check all the fields, right? If you want to check that the A field is equal to 10, the B field is equal to 3, the C field is equal to hello, and so on. Basically, leaves it's more prone to programmer error, right? You might have to change a thing here or there, and then you forget to change it elsewhere, and so on. It's kind of hard to read because now it's on multiple lines or something, or the line's really long. So in Rust, you can basically do what's called pattern matching, and this is where it gets to like the declarative programming part, where you kind of just declare what you want your structure to look like. We say we want our structure to look like A with a value 10, B with a value 3, and C with a value hello. And if it matches that pattern, then we do something. If it matches the next pattern, we do something. If we only want to check the value of A and we want B and C to be any value, then we use the underscore sign or underscore symbol. And for all other cases, we can just use an underscore case at the very end. And this makes it a lot easier to read, and it's a lot less prone to errors. Any questions on this? It looks pretty similar to like a switch statement, but it's a lot more powerful because of the, can we do match on ranges? Like in Fortran. I've never worked with Fortran, but I think you can do like, you can do ORs. And I think they're working on ranges, but it might still be in nightly builds or something. they were talking about doing pattern matching for like more advanced strings and stuff, such like that. Like a switch statement between 10 and 20. You can add if statements to your switch statements, to your match statements. Say like, let me write it up. Something like that. You can do that right now, but I think they're working on ranges. Iterators. I know other languages have iterators as well, but I think it's a lot easier to use in Rust, in my opinion, at least. Not saying that other languages are bad, but here's a problem. We have a search suggestion feature. We're given the user's input and a list of sorted suggestions, and we want to return maybe the first 5 results. So in Rust, we can basically just run it like this. We have our vector or our list of suggestions. We have our input. We do a iteration on it. We filter it so that it only contains the suggestions that starts with the input, and then we'll take 5 from it, and then we'll collect it into a vector, and then we just return it. Pretty simple, and makes it a lot easier to code out. -5 also valid. I don't think -5 works. I believe take only takes an unsigned integer. A tail work. There's like a reverse, and then you could take. So you can reverse the iterator and then take. Okay, so some of Rust's use cases. So Rust actually has a wide variety of use cases, which is why it's being used in which is why it's being experimented with in a lot of different fields today. You can work on system tools like BAT or EXA or WebFetch. You can work on backend with Tokyo, and Rust also recently got async and await support. You can work on the front end with WebAssembly. You can work on game development as well. Embedded is also nice because you can compile Rust without the standard library, which makes your binaries very small. You can also work on web browsers. Firefox has been switching over to Rust on a lot of its components. And there's also the Servo, I believe it's a web engine that's written entirely in Rust. The Linux kernel is also thinking of opening up, allowing people to write device drivers in Rust. Operating systems, there's an operating system called Redux that's written entirely in Rust. You can also write library extensions. So maybe you want to make a new plugin for NumPy or something, you could write it in Rust potentially. Also works for UI. The Google Fuchsia mobile operating system, their UI is written in Rust. You can also write other languages with Rust. The Dino runtime is basically a TypeScript runtime written in Rust, and it's supposed to be the next Node.js. Would you recommend Rust for high performance computing? I do a lot of optimization work that needs to be really close to Metal. And how's Rust for GPU programming? Is there CUDA support? Yeah, Rust is really good for high performance computing. I believe there's good progress on GPU support for Rust. I think there's like web GPU for the web, and there's also other GPU libraries. I haven't gotten myself into it yet, but yeah, you can look around on GitHub and stuff. There's a lot of Rust libraries for GPUs, I think. There's also, yeah, kind of similar to what you said about GPU. We have video encoders and decoders. The new AV1 video format, there's a Rust encoder and decoder for it called Ravi. Yeah, the possibilities are pretty much endless. It's just a bit harder to use than other languages to get started with, but the performance gains is worth it, in my opinion. So who's using Rust today? Well, there's actually quite a few people or quite a few companies that are using Rust today. As you know, Mozilla is using Rust. They're the ones that created it. Apple is thinking of using Rust as well. Dropbox is using Rust for their file system, I believe. Discord is using Rust for one of their services that was previously written in Go, but now they ported it to Rust to have better performance. They wrote a blog on this if you want to go check that out. The Google Fuchsia OS, which is a mobile OS that's supposedly supposed to replace Android, but it's been in development for a few years now and nothing's been happening. Also, Microsoft is also thinking of using Rust. Amazon has sponsored the Rust project. How to get started? What are your thoughts on Go? I heard mixed reviews and haven't needed to use it yet. I'll get to that in the end. How to get started? So there's the rustup.rs website, and this one is gives you a script that basically installs Rust for you really easily. It's an automatic installation on the command line, and then also it installs the rustup program, so you can update your Rust whenever. You can install nightly builds and beta builds and so on. They have the official Rust handbook that teaches you how to use Rust. And if you want to learn Rust using example code, then there's Rust by examples. You can also check out the Rust Reddit, and you can also there's also a Discord server for Rust. It's also YouTube. I liked tensor programming, and John Genset is pretty good. I also made some YouTube videos on Rust, so you can go check those out. Yeah. Well, thank you. And if you guys have any questions, I'll be here. To answer my thoughts on Go, I actually made a video on it, so you can go watch that. It's called, what was it called? Something like 5 reasons I don't want to use Go or something. 5 problems I have with Go. So I guess you can kind of tell what my thoughts are on Go, I think. But I think Go is like, it certainly has its place in the world, and like you use it in DevOps and stuff. But for me, whenever I was using it, it was really painful to use. But it does have decent performance. So yeah, do you guys have any questions? It has more likes than dislikes though.
Hello?
Yeah.
So Jeff, you mentioned that you had quite a few problems with Go.
Yeah.
Are there any problems that you have with Rust?
So far, not really. It is hard to use sometimes. Like you have to write a lot of boilerplate. I tried writing my website using Rust and WebAssembly, and it was a lot harder and a lot more code to write and a lot more work to do than like spinning up like a Crave React app. So this thing's supposed to end at 6, so we have like 15 minutes. How long do you? How's metaprogramming in Rust? Like, are you talking about macros? Macros are pretty good. I dabbled with it a little bit, but I didn't find any use for it in my introspection, design-oriented development. I do not have experience about that, so I cannot say. Basically running things at compile time. Do you have any examples? If you have a sort function. I don't think I've ever ran into that, so would use if const expr. I don't know about that, sorry. I don't think they have anything like this, but I also haven't gone into metaprogramming that much, so. Get the name of the methods of a class at runtime. I think you could do that. I know there's like, you can make like macros that automatically implements something for you or something. Or like automatically implements a class or automatically implements, I mean, not a class, like a trait. Check, does this class have iter method? Is this a common thing? If you're, I think in that case, you can basically make a trait and then implement the trait on the class, have like a macro that automatically implements the trait. You can have, what are they called? Decorators, like you can have derive. You can have something like this, derive, debug, and clone on top of your structure. How to introspect all available methods on, let's see this. It has a Python API that can parse instances. Okay, yeah, the answer says currently there's no such built-in API to get the fields at runtime. However, you can retrieve fields in two different ways, declarative macros and procedural macros. Yeah, so looks like you'll need to use macros to do some of this stuff, but it's pretty non-trivial. Yeah, I'm not saying you're afraid of macros. I just haven't used macros enough. What problems would you say Rust does best? I think it's really good at replacing C++ for a lot of older code bases, especially ones that are really multi-threaded, because Rust is really good for thread safety and all those other memory safe stuff. So let's say maybe like a game engine, or I don't know, like a web engine, something that is going to be spawning a lot of threads. For example, Firefox's CSS parser before was written in C++, and it had to parse CSS sequentially. And whenever somebody tried to parallelize it, they always end up having these really weird bugs. But then when they switched over to Rust, it was like, it just worked pretty much. I'm not that familiar with C++, but yeah, I think though there's definitely use cases for C++. Maybe if for sure you know that your program is correct and it's not doing anything crazy, but Rust keeps complaining that it's doing something crazy, then yeah, I think C++ would be a good option. One of the downsides to Rust is like when you compile it, everything is statically linked. So your binaries might get pretty big. Whereas with C and C++, you can dynamically link all your libraries. So your binaries can be pretty small. Compiler optimization, I think it's pretty good. It uses the LLVM. Yeah, it goes with LLVM. Just Rust C. All right. Well, if there's no other questions, I guess that's it for the talk. Thanks everyone for coming.